Good morning, everyone. Thank you for coming here and joining us in person for the technical paper presentation session during India Smart Utility Week 2023. And we will just now start with the session. First of all, I would like to thank all of you for submitting the abstracts, working on the papers, and the best chosen papers are here with us right now. The first chair of today's session is Mr. Sameer Chaudhary. He is honorary member ISGF. The themes he'll be covering today will be cybersecurity for digitalized grids, disruptive innovations for utilities, smart grids for smart cities. Sir has over 40 years of experience and has an extensive experience in the Indian power sector for 29 years and over 11 years in the information and communication technology domain for the Indian state-owned Maharatna Company Power Grid Corporation of India Limited. So with that, I would like to hand over the stage to Mr. Sameer Chaudhary for opening remarks, and maybe we can start with our first presentation once sir is done with the opening remarks. Sir, over to you. We can hear you, sir. Please go ahead.
Yeah, very good morning and welcome to this virtual session of technical presentation. I welcome all the participants. We have got a very enriched and very renowned panelists from government sector and private sector, and even we have got international participants. So I welcome you all. This is to be, I think, a long session with 13 presenters. So I welcome and I request the first presentation from Srimati Devika J.
Sir, would like to inform that Ms. Devika had some personal emergency, so she'll be joining us in a minute. In a few hours. So, what we can do is we can start with our second presentation by Mr. Mukesh Gadvi.
Welcome, Mr. Mukesh Gulab Singh Gadvi. He is from SLDC Getco, Gujarat. Welcome. You can start your presentation, sir. We are very glad to listen to your presentation.
So please come here on the dais. Sir's paper was situational awareness for grid using wide area monitoring and analytics based on VAMs. It is a GetCo project. So I'll just load sir's presentation and sir will start.
Thank you. Welcome.
Thank you, sir. I would like to thank ISGF and India Smart Utility Week Management for giving me this opportunity to present my technical paper on situational awareness of grid. In fact, improved situational awareness of the grid using wide area monitoring system and analytics based on the wide area monitoring system. It's a JETCO project. I'm happy to inform you that this JETCO project has been nominated for the award in Smart Grid in Transmission Utility, which will be declared today evening. As we all know that Indian grid is basically run since years by inertia-based machines. Maybe it's a coal-based machines or maybe it's a hydro, nuclear or gas. All machines are inertia-based machines which gives synchronous inertia for the grid stability. But the situation has changed in last 10 years. Large penetration of the renewable energy has changed the scenario. And other regulations, numbers of regulations has also changed scenario. That is why the new technology is required to be in place for capturing the dynamics of the grid. Previously, whatever the technology available up till now is not able to capture all the dynamics of the grid. So in future, if you think about the future, so many changes are coming up, like balancing mechanism of battery storage system, or say a pumped hydro mode, and say the green hydrogen is going on and on. So to capture the dynamics of the grid in real time and to improve the system operators' confidence, a new technology like wide area monitoring system is required to be in place. And JETCO I am proudly say that JETCO is along with the Power Grid Corporation of India is pioneer in implementing smart grid project in our grid. You can take an example of the Gujarat. The Gujarat is one of the renewable rich state which is having at present 36 gigawatt of the installed capacity, out of which almost 36% is coming through renewable energy installed capacity. And last year, around 13% of total million units were generated through renewable energy. And the way the solar energy is increasing, like in last 2 years, solar energy in Gujarat has doubled. From 3,000 to from 4,000 megawatt to say around 8,000 megawatt solar energy has been increased, 8,600 in fact. So considering this fast pace of increase in the renewable energy and very ambitious projects are coming up in Khavda near Kutch area, 10 gigawatt solar energy project is coming up in 3 or 4 years it will be commissioned. So looking to all these things and looking to the inertia of the grid is reducing, monitoring of grid is becoming critical day by day. So there are challenges which power system operators faces. It's very common, but just I have taken up because why this new technology is required. So as I say that brisk pace of capacity addition, like 10,000 megawatt is going to be implemented in say next four years or so, and that will be in the area which is called the Khavda or Kutch area. And to transfer this power from this Kutch area where there is no load to the load area of the Gujarat, that is maybe south and middle of the Gujarat. That is one of the challenge, and that is why one of the reasons that technology is increasing. And we are all talking about the climate changes. So yesterday also I was attending the conference, and one of the International Finance Corporation has said that if we integrate more than 200 gigawatt of solar, renewable energy, it will be very difficult to integrate next renewable energy in the grid, because our target is 2030. We are going to integrate as an India as a whole 500 gigawatt of renewable energy. So without balancing mechanism, without using new technology, it will be very difficult to integrate more than 200 gigawatt of renewable energy. So, and day by day customer expectations are also increasing. Customer wants a proper data, real-time monitoring, real-time data. So that is why we are for improving the situational awareness of our power system operator. In 2012, when major grid collapse occurs in north and northeast area, even CERC and CEA also recommended that recommended installation of PM in all strategic locations to prevent the system instabilities. So there are other regions like at present all the grids are run by through SCADA system, which is redundant system, and there is a very well placed system, and all the all the utilities are using the SCADA system, but SCADA system is having two difficulties. So its data comes after 7 to 10 seconds. So that is the latency of the data which becomes the historical data. It doesn't give any present screenshot of the system. So PMU data can give which come in 20 milliseconds or 40 to 20 milliseconds, which can give the present screenshot. Also PMU data is timestamped at GPS timestamped at PMU level. So it has a reference phase, and so that the grid can be visualized in real-time basis. Considering that in the year 2016, JETCO has installed the first phase of the wide area monitoring system along with PGCI, and we have considered 25 strategic locations where we installed 113 PMUs. This system is at present running in our Gujarat grid, and we are getting benefits of this system at present. So looking to the complexity of the grid, we have planned in the year 2020 to install go for the wide area monitoring system phase 2, where we are installing new 62 locations and around 250 PMUs we are installing. 70% of the work has been completed as far as the field work is concerned, and remaining remaining work at control center, we are at FAT has been completed, and SAT is going to be started in the next April, at the end of this month or 1st of the April. So this is the total then total wide area monitoring system will be commissioned. Total 87 locations we are installing PMUs. Total 363 numbers of PMUs will be installed, which will cover 63 to 20 kV substations and 20 generating stations. And total 1,515 numbers of elements will be monitored using this PMU technology. So when we implemented the first phase of wide area monitoring system, at that time we took an unique project. Like in coordination with the IIT Mumbai, we have developed one R&D project which took 3-4 years to develop the analytics based on this PMU. See, when we are using accurate data, it can be useful only when we can have some analytics and it's available at operator's console. Then only this data will be useful. So in first phase, we have developed 3 analytics based on the PMU data in coordination with IIT Mumbai. It was an R&D project, first kind of a project we have done as a government utility. So there we have developed 3 analytics. One is the online oscillation mode identification, state estimation of the grid. This analytics are present working in our SLDC control room, and voltage instability and early warning system. This analytics we are using day by day in our control room for visualizing magnitude and angle of all 3 voltage, current, phasor. We are getting sequential components at our control center. ROCOF, that is our rate of change of frequency, continuously monitor at our based on this wide area monitoring data. And we have divided our grid into 4 zones, and we are monitoring the angular separation if any between the pair of the nodes, that is from south to west or west to north region. So we are using it for analyzing of different type of the fault, because this is also useful in analyzing the post-fault analysis, like which type of the fault was that, what was the sequence of event, because it gives very accurate timing of sequence of event, and whether protection is operated or not. We have based on this data, we have replaced so many 2 or 3 CVTs by knowing the voltage profile of their particular 400 kV location. So we have saved that lines from tripping. We were detecting ambient automatic ambient conditions of say any oscillations is in the system. 2 or 3 times oscillation has been detected. Once at nearby Tarapur Atomic Power Station, and between Tarapur and Vapi we have detected some oscillations. I have taken a screenshot of that also, and that oscillation has saved. That oscillation is having a good damping factor. So you can say that Gujarat grid is in stable condition, we can say. In the second, this is the second phase of our architecture for the wide area monitoring phase 2. So what we are doing in this, we are installing 60 to 250 PMUs, and we will integrate the PMU from the first phase, all the PMUs, plus it will integrate the WRLDC PMUs. It will integrate the URTDSM PMU pulled by PGCIL in our area. So all the PMUs will be integrated in one phase 2 project. So data from the PMU will come through our JETCO's fiber optics network. We have laid around 10,000 kilometers at present, 10,000 kilometers of OPGW and 7,000 kilometers in under pipeline. So 70% of the grid is connected through our JETCO's FOT network, OPGW network, and rest 30% data is coming through can say lease line or some another communication medium. So this data will go to PDC, and PDC we are having different servers like application servers and synchrophasor servers, and that data will be going to historian server, which is having capacity of 1,000 terabytes capacity of historian server we are going to place, and all the servers are having a redundant facilities, and all the data is coming through cyber security through firewall, and from synchrophasor gateway it will be available to remote workstation. We have planned to give remote workstation to our ALDCs. We are having 3 ALDCs. One is northern area, one is the central area, and one is in the western area of Gujarat. So, and one remote workstation will be available at our corporate office. Also, this data coming to PMU, we will give to analytics servers, where we are going to develop new analytics, which is under tender process. We are also having NMS, that is network NMS system in place, and that will continuously check the network management of this architecture or this wide area monitoring system at up to the PMU level. So in first page, these are some technical specifications of PMU which we are using. It is having C37 2011 standards, having a sampling rate of 50 samples per second. That is, it will give data up to in 20 milliseconds. One of the thing I would like to mention is that as far as control center scaling is concerned, it is world's largest project. We are doing because we are going to integrate 16. It is having capacity of integrate 1650 PMUs and more than 3,000 locations can be more than 1650 PMU can be integrated in our control center. It is having two redundant, that is 1650 plus 1650 PMUs can be integrated in one control center, or that to 20 millisecond data. It has a capacity of integrating 3,000 PMU maximum, 1650 in one in redundant mode. So this is the world's largest project as far as control center scaling is concerned. And also this control center is having a facility to integrate data with SCADA, and along with the SCADA data and PMU data, we are generating some screens available to the operator, which is whatever the screens available in SCADA, which is available using the PMU data. So that is one part. One thing world is also thinking that whether can a PMU data replace the SCADA or not. That is where because C37 118 PMU is having certain limitations on graphics side and that data is also very fast, 20 milliseconds. So we have also checked in our FAT that all the screens available in SCADA can be available through wide area monitoring system data. So actual picture of the grid will be available using this data. So we have planned some analytics also. So whenever you are using some technology, it can be useful only when you can utilize it in a proper manner. Only data coming and looking may not be that useful. So we have planned certain analytics which is under pipeline, under tendering process. It is already planned. So first two we have planned that islanding detection and resynchronization application. So using the PMU data, if any island occurs, immediately we can know that the island has occurred, and all the data of the island will be available. Power data, current data, or voltage data it can be available at the operator console, which can be used then it will be very useful in resynchronizing application. Looking to that data, we can take a decision whether we can resynchronize or not, or what time it will take to resynchronize this island. Another is generator trip and load trip detection application. That is where major tripping occurs, whether it is generator trip or load trip. It can identify the first PMU location from where the tripping has started. So we can take a decision again for the resynchronizing or restarting of the lines and all these things. Third one is also very useful and very useful application as far as the grid stability is concerned. Voltage sensitivity and voltage angle sensitivity. That is, if say 100 megawatt or certain amount of the change in the power, how much change in the voltage will occur, or certain amount of change in the power, how much voltage angle will change in that area. So that is that shows the grid stability. That is, PV curve or QV curve can be generated using this voltage and angle, voltage sensitivity and voltage angle sensitivity. So that is very important because this curve sometimes shifts very drastically, which can lead to the cascade tripping or some grid tripping area. So if we can have this sensitivity in advance, we can take certain steps to avoid the cascade tripping. Another is oscillation source location. On the first page also we have developed this online oscillation monitoring system, but this time we are thinking to go further, that oscillations will be identified, its magnitude, its frequency, its type of and mode of the oscillation can be identified, and it can identify the first PMU from where the oscillation has started. So when we can monitor the oscillation in the system, we can save we can use it for tuning of PSS or tuning of AVR in the generator. If some oscillations are coming, we can check this oscillation and can use this as a tuning of PSS or tuning of AVR. Also, monitoring of the FACT devices also can be done through some oscillations are there. There can be some issue with the FACT devices, or sometimes in the grid resonance occurs, and oscillations may occur because of the resonance. So that can damage the generator blade or turbine blades in the power station. That can be saved if this application we are planning for that. Already we have discussed much about the inertia, reducing inertia because of this wind and solar penetration, particularly solar in penetration. Some of the wind provides certain amount of inertia, but solar can provide almost nil inertia. So for the future, monitoring of the inertia will be very important. If you can monitor, you can control. So this application, that is real-time monitoring of system inertia, and one of the application which is our engineering department also required to add into this, that is a short circuit ratio of various RE connected buses. So that analytics we are planning under tendering phase, and we are planning, and of course offline advanced studies tools. That is always useful, because when any fault is occurs, then analyzing in the based on the real time data is always useful to save in the future grids. There are certain key benefits, so that is okay. Fast and accurate detection of the islands, or say multiple islands can be detected. Accurate detection of generation trip, identification of the first responding PMU location, closing to generator trip or excessive wear. These are some key benefits using the synchropressure data. Main thrust will come when we can develop some algorithm, and algorithms such a way that this algorithm can be used for the special protection system using wide area monitoring system. This day has not come, but this day will come that we can develop certain algorithm, certain events occurs in the grid. Automatically, based on this algorithm, wide area monitoring based protection system will operate, and that will save the grid from tripping. So that is the concept of the self-healing grid is all over the world, and many people are working on that. Few of the this has been implemented also. This is called WAMPAC, that is wide area monitoring based system, protection system. So that will be the future. Concluding, what I would like to say that this wide area monitoring system is the future of monitoring the grid and capturing all the dynamics of the grid. This system is very useful. In future, this system may replace present SCADA system if as what we have planning, and we can successfully generate all the graphics and all these things using this wide area monitoring system data. Then future it can replace. And if you see the cost benefit ratio of the SCADA, this is cheaper than whatever SCADA we have implemented, because we are going to change the SCADA in year 2023. That cost has come approximately around 170 crores, and what we are implementing is around 35 crores. Of course, SCADA can be more than that, but all the stations cover, then that can be more than that. But still, it's cheaper than whatever the SCADA system presently working. So in future, it may replace the SCADA system, and it will accurately give the real-time monitoring of the grid. And that this project again, it is this one screenshot I have taken about our oscillation which was observed nearby Tarapur power station, that is atomic power station. That's it. Thank you for patience listening. I hope you enjoyed my presentation. Thank you.
Presenters and all the participants have got their immense knowledge enriched through your presentation. Thank you. Parul, next presenters, if you can call.
Yes, sir. So our next presenters are from Tata Power Company Limited, Mr. Ravi Sahu and Mr. Ashish Mahatre. Mr. Ashish Mahatre from Tata Power Company, and their paper was monitoring of remote substation through robotics, augmented reality and artificial intelligence. So I'll just load their presentation, sir.
Okay. Welcome by the time Mr. Ravi Sahu and Mr. Ashish Mahatre. I think you will be covering the most contemporary and most hot subject, that is artificial intelligence. We are very eager to listen to your presentation. Thank you. Welcome.
Thank you, sir. Thank you. Respected dignitaries and all my friends here, a very good morning from Tata Power team. On behalf of our team, Tata Power Transmission, we are presenting interesting use case, a practical implementation in Tata Power. So today's topic for our presentation is monitoring of remote substations through robotics, through augmented reality, and through artificial intelligence.
Fantastic, fantastic. In fact, your designation is very intriguing, specialist innovation. Okay.
Thank you, sir. I try to be a specialist, but still not a specialist. Thank you, sir.
Yeah, okay.
So, going ahead, this is the landscape of our project which we have implemented in transmission. On your right hand side, you can see the robo, which is at remote location, which is kilometers apart from our location where we wanted to monitor. This robo is completely automated, taking station rounds. And thanks to our very rugged communication network, we have a very good fiber optic network which brings in this data to the central control center. So we are getting live feeds from this, and thereon we build up our augmented reality and artificial intelligence in the database. So here you can see in the landscape that it's a painstaking effort to put up a database for augmented reality. The entire mapping has to be done. And after a lot of failures, we got to successfully develop a database for the augmented reality of this substation. Thereafter, after developing this database, it has been transferred to the monitoring systems, and all this is happening real time, guys. So real time video feed is coming, the augmented reality is embedded on the video feed, and it is presented live to the operation engineers which are sitting remote. Plus, the alarms are also observed. And it has various other applications also which we will discuss further in the slides. So this was about robotics and remote monitoring for you.
So the trigger for improvement for implementing this project was we have a remote substation at our Granto receiving station, and we are sitting at Karnak receiving station. So it is an unmanned station, and we are controlling that station sitting at Karnak. So the earlier practice was that the operation engineer has to go there at remote substation for condition monitoring. He has a paper-based checklist. He will fill the data and he will report the normal and abnormal conditions. So what happens in the there is a huge these substations are situated at South Bombay. So there is a huge traffic, and in case of rainy seasons, the people will not able to go there. So we have done the brainstorming, and we have list out the points that multiple rounds of traveling is required for troubleshooting, coordination required between various O&M teams at site during emergency situations, and there is absence of centralized information due to multiple OEM legacy equipments, and historical view of real-time electrical system information. Status of equipment was not always available in the field, and virtual view of law equipment was not available, as the person has to go there, travel to the unmanned station, and possibility of human errors during complex procedure can also lead to safety incidents. So the relevance of this remote monitoring substation, what we have developed, what is the uniqueness of this project? First of its kind substation monitoring robotic system, fully automatic and loaded with advanced augmented reality, virtual reality and artificial intelligence features. The robot is automatically starts with the station rounds. It is programmed with that and docks itself to the charging, that is called the parking station for the robot. All observations of O&M rounds are taken by remote robot program to work in 3 shifts. Like the operation engineer go there, take the data in 3 shifts. So the robots are programmed so they can take rounds in 3 shifts. Virtual reality and augmented reality dashboards are built on centralized workstations. Historical reports are stored in and also viewed in email. So after completion of the round, report generated and it is triggered to the authorized emails, so that they can view it every end of the shifts, what are the normal condition and abnormal conditions.
So as Ravi said, all this is happening real time, as well as the augmented reality database is also getting embedded on the real time. So main thing with this project was to getting the live feed to the remote substations. That was our initial aim. Thereafter we started brainstorming and taking some efforts to put data or augmented reality into this live stream. We were successful doing that. Then we thought that why not alarms can come on the augmented reality and it can point us what are the abnormalities the robo can detect by using the live feed as well as the augmented reality. We were successful on doing that, and then after storing and giving the dashboards to the station manager. So we reached all the success points and the challenges which were there to reach that site. Now no person goes to the site, so it's all happening automatically, what Ravi has already explained. Then actual use case I would like to explain in detail. This is a Grant Road substation. We have a central node at Karnak, which is South Bombay. These are kilometers apart, and what difficulties we were having is that it's a very crowded area. It takes about an average of 45 minutes to go to that place, and sometimes more. Filling the dashboards and the dash sheets, although they are automated, still it takes around 20 minutes more. So in and all, about 2 hours it takes for a station round, and you are gathering about 60 points on the checklist. So this was the pain point, and this was the you can say the station which was pointed and given by the management. Okay, you work on these stations where it is difficult to reach. So here we wanted a cycle time reduction. Even the person traveling, the vehicle management, everything gets zeroed in once you have these kind of automated systems. So we are benefiting much from this particular implementation use case. So this is the actual implementation use case, and we have started the station rounds for few months, and we are very successfully doing that.
So the actual implementation of this will describe about the robot. This robot is developed in-house within Tata Power. So this robot is a line follower having line sensors for detection of path. So we have proximity sensor for detection of obstructions. It is equipped with a camera for giving the live feed to the central location, and it is moving on a slider mounted on the robot. The robot is powered by 12 volt 7 ampere hour battery, so that with the full charging of this battery, the robot can take 3-4 rounds, and the camera resolution is 12 megapixel with 5 times optical zoom. The RFID sensor, that is radio frequency identity detection sensors, are present for detection of RFID tags. Remote command web server development relaying camera footage is done through the ARM processor, and motor control is done through ATMEC controller. So the idea of this robot comes, earlier we have done this, developed this robot inside our Tata Power with the in-house, and we have done a project robotic isolation of 33 kV vehicles. So we have an idea about this robot. So we have combined the artificial intelligence and virtual reality features along with these robots for condition monitoring.
So here's a video, guys. I hope it's streaming.
Yeah, please carry on.
Yeah. So you can see this is a robo which is taking the rounds. This is the remote Grant Road substation. Now you can see the movement of the camera. It can go up and down, and right now it is scanning the panel and the equipments inside the panel. So this is the robotic movement for you. Each panel it will stand and scan. At the remote site, you are seeing this picture. Here you can see the same thing, but with an augmented reality. You can see the pop-ups which is coming in blue. This is augmented reality. It is identifying the equipment. It is also identifying which type. It can put lots of data in the real-time world. And now you can see once the robo goes up, it can even identify the abnormalities from the respective ID. So it has identified this is a particular relay. Now this is the live feed. You can see it can also identify the abnormalities from the relay which is there. Finally, the robo comes back, does its jobs, and dock itself after taking a station round.
So the key takeaways and recommendation from this projects: the conventional process of O&M condition monitoring has changed through this innovation project. O&M personnel benefit with the significant saving in time, cost, and efforts. More stations can be added for this daily maintenance rounds. So we have already taken up this project for horizontal deployment, and we are developing 2 or 3 robots for other stations also. And it has a ease of recording data and abnormalities on the go. Customize advanced augmented reality view dashboards, hence physically carrying manuals, logs, logic data, data sheets is not required. This will save significant time in maintenance operations. Effective tool for training new engineers on all different OEM makes and types of system equipments, and this centralized server Storian for remote monitoring.
Yeah, thank you, friends. This was our presentation today. Thank you.
Thank you for your scintillating presentation, Mr. Sahu and Mr. Mahatve. This is par excellence example of the Industry 4.0 in reality in power system. One question here, how is the cyber security aspect is technically taken care? You can just, if you can clarify.
So very good question in terms of recent alertness for all the substation monitoring, where we actually have a cyber security implementation at all the substations, right from the remote substation as well as the control center. So both are coming through a secured network. Also, we are using our dedicated OT network for this particular application. So no other application is coming through this particular channel. So this particular cybersecurity aspects from day one we were aware of, and we have taken care of the cybersecurity things.
Okay.
There was a challenge where you have choice between the quality of what we are getting video feed, whereas the cybersecurity. Once you have firewalls in place and many active components in between, so there is observed that there is a lag when you get a data at the other end. But however, we didn't compromise on any of the cybersecurity norms. We followed the standard channel, and we, in fact, our communication team established a dedicated channel from the robo directly to the server. So that's how we have eliminated all the chances of any intrusion in this particular network. It's a dedicated SDH network for this particular implementation. Thank you.
So it appears you are deployed IoT technology also. That's what it appears, isn't it?
Yes, sir.
Yeah. Thank you very much for your informative presentation. Thank you. I think all the participants and the presenters also have got a lot of benefit from your presentation. Thank you. Yeah, Parul, next.
Yes, sir. Thank you, Mr. Sahu and Mr. Mhatre for a very good presentation. Moving ahead, we'll be having our third presenter over here. So next we have with us Mr. Ganesh Mane from Tata Power Western Odisha Distribution Limited, and Mr. Anil Kumar Oja, Head Technical Services, Tata Power Western Odisha Company Limited. And the paper that they submitted was Rural Digital Substation. So I would request them to please come on dais and present their presentation. I'll just load the presentation, sir.
Okay. Welcome, Mr. Ganesh Muralidhar and Mr. Anil Kumar Oja. You have got a very, sensitive topic, rural digital. Okay. So this is the hot topic today, rural digital, and welcome to you. By the time the presentation is loaded, people will be eager to listen to you because rural population is more than 60% over here, and so the distribution is taking the center stage in the rural electrification area. So we are eager to listen to you. Your presentation. Welcome.
Good morning, delegates, and good morning to the chair of the session. Myself, Bobin Chako, and I'm assisted by Mr. Ganesh Mane. We both represent Tata Power Western Odisha Distribution Limited. Unfortunately, Mr. Anil Oja couldn't make it today, so I'll be taking over in his absence. So just to give you a brief perspective about TPWODL, so we are serving almost 88 lakh population on the western side of Odisha, covering almost 48,000 plus square kilometers of area, almost 21 lakh customer base. And the best part of Western Odisha is that we have industrial customers. You can say Rourkela, the Rourkela Steel City is on the northern part, as well as we also have agriculture and rural customers spread across the central and the southern part of Western Odisha. So there is a huge shift in the kind of customer base whom we are serving on the western part of Odisha. And when it comes to distribution sector, reliability is one of the key KPIs for any distribution companies. So reliability improvement, taking this KPI, which is the most important KPI for our organization, we did a survey, and the primary substation which are spread across Tata Power Western Odisha, the Western Odisha part, which covers 5 circles, you can see the condition of the primary substation. It's very, very poor. And when we went into the reliability analysis, we found that the modernization of the substation is one of the key aspects if we have to give reliable and optimum power to the customer. Now, what are the challenges for this PSS modernization? As you may already know that for a 33 by 11 kV substation, there are a lot of control cables. So the infrastructure consists of control cables, you have protection systems. In today's world of numerical relays, there are substations which are served by electromechanical relays. Civil work, trenches, control rooms, a huge cost is involved into refurbishment and modernization of these. And of course, the high turnaround time and the cost. So if you are supposed to take a shutdown of a primary substation, so you can imagine the kind of agitation which the people we would be facing from the customer because of the high outage time. So looking into all this, there was a small team which brainstormed into all of these challenges and came out with a very unique solution, which we felt would be the solution to improve the reliability of the entire system. So the rural digital substation came into being, and taking this forward.
See, the conventional CRP based approach I would like to show here. So there is a 33 by 11 kV substation, and 33 side, 33 to one line is incoming, one outgoing line, and 2 transformer. This is a typical scenario where we are facing means in our Western Odisha area. So control room is having this type of CRP panels, and all these CRP panels are placed in one control room. So this is a huge control room size required, as well as we need to lay so many cables. We need cable trenches as well as we need RTU to be installed to make it communicable and all. So the concept of rural digital substation is came after the brainstorming session which we have conducted within our teams. So what we have done, we have placed the remote terminal unit only in the control room along with the ACDB, DCDB. And after that, all the micro CRPs, we have converted the big CRP panel into micro CRP. And this CRP panels placed on the breaker structure or a outdoor CT structure. And from there, for transformer protection, we have again put the transformer differential relays in the panels below the transformer, around the transformer area. And all these cables, the required for the communication establishment as well as AC connection and DC connections, so we have laid through HDP pipe. So we have we have done complete replacement of cable trench work with HDP pipe, as the number of cables run is reduced drastically. So we don't have to lay the control cables from control room to particular CBs, because we are installing CRP panel below the circuit breaker itself. So our total CT connection, PT connection, as well as the control cables got drastically reduced. So this is the sample actually what we have shown here. So this is the size of micro CRP panel which we have installed. And this CRP panel is taking care of all the BCPUs, metering functionalities as well as control, and it is directly installed on the circuit breaker. And small for operator control and monitoring, we have given a HMI. It's a local SCADA, we can say that, from where he can able to see the complete health of the substation. So the comparison what we have done with respect to the conventional and RDS, rural digital substation. So the time reduction what we have envisaged is 1/10 of the conventional approach. if we have to go with the conventional approach, there are so many work we have to do. Even the transportation of CRP panels, it's also a big task. So all the tasks we have reduced, and we found that the commissioning time and the modernization time is only 1/10 of the PSS, and the cost reduction is around 62.8%. So this is the even means we have done the detailed analysis with respect to transportation of panel, as well as the installation, testing, commissioning of the panel, number of outage. See, actually Tata Power has taken that particular area to improve the reliability. And to improve the reliability, we have to take so many outages. So people are saying, no, it's earlier was good because you are taking so many outages. So such a scenario we have tackled by doing this type of innovation. So this is the execution where we have implemented the particular RDS project. So earlier there was no CRP panel below the transformer and the circuit breaker. So installed this micro CRP there, and it has communicated with SCADA, and even the units what we have installed are able to give the disturbance records also at one of our central location. So we have implemented this successfully at our Atabira substations, and we have taken care of sustenance part also. And as far as sustenance is concerned, see, as we are putting this panel outside the means open to environment, so we have ensured the IP54, as well as the area western area is having huge surge actually. So we have taken care of surge protection, as well as the temperature range is very high there. So we have taken care of that as well. So all the sustenance perspective we have taken care, and way ahead we are thinking to convert this particular approach to a digital breaker itself. So instead of putting that CRP panel below the structure, we are procuring the panel which is having CRP functionality itself. So we are discussing with OEMs and asking them to provide solution like this. So we don't need any control room. Many a place in Western Odisha we found that control room itself not available. Panels are very old type. So we have taken care of this part here as well. And also we are thinking to replace this micro CRPs with a fiber reinforced polymer actually, so that there will not be any effect on the environment on the panels. So this is the benefits actually. Customer, we are saying that minimal interruption, as well as the utility, we are able to improve the reliability within shortest time, as well as all the control and monitoring of the substation, as well as transformers and all, we could able to get centrally. And cost reduction in the cable trenches and control room, this is the biggest aspect actually. And the main point, worming proofing is not required because we are using HDP pipe, so we could able to seal that properly, so that there will not be any damages due to the rats and all. So again, reduced transportation of vehicles and greater CO2 saving actually. And scalability, we can say that we can implement this solution around 400 PSS. We are calling it as a PSS, primary substation, over complete Tata Power Odisha. As well as other discoms, we are considering this solution can be implemented more than 5,000 PSS in overall India, because everywhere the scenario is similar. So key takeaway is that using this RDS methodology typically will improve the reliability of the power supply within shortest possible time actually. And our OEM is also appreciated for this because they are having this kind of product actually, but they haven't utilized it since last 3 and 4 years. So our idea actually helped them to utilize their product as well. And our synopsis also got selected in the SIGRE 2023. So thank you.
So thank you, Mr. Mane, Mr. Ojha. This is really an innovation because digitalizing the distribution system in the rural area. This is also environmentally sustainable project, environmental friendly. I was just having one query that when you have gone digital in distribution, what are the cyber security aspects you have taken care? You can just
see, as Ashish told that in earlier presentation also, means we are one Tata Power only, and everywhere in the substations also we are putting our firewall system, as well as at central SCADA location we are also having a firewall system. So we are taking care of all these cybersecurity related functionalities, and even we are doing frequently testing also. See, many of the equipments are having the standard passwords and username. So we are changing up to that level so that nobody can enter into the system, and this is the we are taking care of this.
Good, good. Thank you very much. It is a really innovative project. We have already executed. Thank you so much.
Thank you.
Our next speaker for the day is Mr. Mausam Datta, Distribution Engineer, CSE Limited. I believe he's here. Yes, thank you. And the paper that they are going to present is drone-based surveillance of overhead LT network. So, yes, I'll just.
Not clear who is presenting.
Sir, it's drone-based surveillance of overhead LT network.
By presenter?
Mr. Mausam Datta, Distribution Engineer, CSE Limited, sir.
Okay, from CSE. Welcome, Ms. Moham Datta. Welcome for your, I think it will be very exciting and interesting for the participant. You can start your program.
I'll just load their presentation, sir. Give me a moment.
Okay.
Good morning, sir. I am Moham Datta from CSC Limited, Distribution Engineer.
Yeah.
I will be by presenting on the topic drone-based surveillance of overhead LT network that we have implemented in our system. And to start presenting of the topic, I first actually discuss about my company, the CSC Limited. It is India's first integrated utility, and it has been since 1899 generating and distribution power in Kolkata and Howrah over a licensed area of 567 square kilometer. And it has a huge consumer base of around 34 lakhs with 700 HT consumers, and it includes domestic, industrial and commercial users. And while delivering power to this vast area of vast area and all these consumers, we have both underground and overhead network, and we have around a long length of overhead LT network. And these overhead LT networks are very prone to faults due to overloading problem in summer months, and due to the geographical location of the Kolkata, and Kolkata has been struck with repeated natural disasters like the former cyclones, deluge, also nor'westers and torrential rainfalls are common in the monsoons, and these affect the network of the overhead LT network very much. So we were in urgent need for a smart, intelligent and preventive maintenance of this overhead LT network to reduce the number of faults, so that we can reduce the span of power outages and increase customer reliability, and also reduce manpower cost and other costs due to fault repairing and others. So in this, so we have implemented this project in our system, the drone-based surveillance of overhead LT network, as a method of preventive maintenance of this vast overhead LT network. By implementing project, actually we are implementing a smart monitoring and maintenance of this overhead LT network that allows us the identification of vulnerable conditions in overhead network that are invisible to human eye. For example, we can say that the main thing that we are implementing in this project is the measurement of hotspots in the overhead LT network, and that are these points, that is the conductor joints, jumper connections that are very prone to faults during summer months or deluges, and we can measure using the thermal image cameras that has been installed in the drone system. These hotspot points are actually invisible to human eyes, but we can measure and actually see how much hotspot is generated, and how is the variation of that things in this system. And more and along with that, the proper identification of vegetation management is also possible with this with normal 4K cameras installed in the drones, and actually we are generating reports and videos and pictures of the whole LT network that we are monitoring. So the vegetation cover that can harm our LT network can be identified. And last thing is that by implementing this smart monitoring, we are optimizing manpower and budget usage so that the weakest point can be identified, and we can as a proactive maintenance system, we can carry out the network maintenance so that we can reduce the faults. Now, for going into the presentation of the topic, we have to talk about the parameters that need to be selected so that which parameters are we want to monitor for proper proactive maintenance. The first of all, the main thing that I have talked in the previous slides, the hotspot in the jumper and conductor joints are the weakest point in the overhead LT networks. The main thing that we are measuring is the thermal cameras, and along with that, with the vegetation covers using the pictures and videos, the sag in the conductors that are very harmful for local people and others, that can be dangerous, that is also taken care of, and other with that, the non-optimal condition overhead poles and physical warranty in the conductors can also be monitored. Now, for the implementation of the projects, the first step is the selection of the route map. For considering the route map, there we have around 8,500 transformers in our distribution system, and we are selecting those transformers that are mainly catering to the completely and overhead LT network, and we are actually in the first stages we are actually implementing this project in those networks that are more prone to faults and has historical nature of prone to faults during summer and storms and peak summers. And we are also analyzing transformer loading data for the conductors and LT overhead network that are electrically stressed, and using the blending of data and also the human experience we also taken care of, because previously there was no scope of actually monitoring the LT network using this drone system or others. So we used to monitor this system using human experience only. So the vast human experience that we have by virtue of our past technicians and others, we are blending this, and this is how we are selecting selecting a priority list, and then according to the priority we are implementing this project. And also due to the use of drones in the areas, and we are also taking care of the constraints provided by the DGCA, so that there is no breach of the licenses. And the second step, while implementing this, after selection of the route, we actually are flying the drones over across the whole length of the LT network for a particular distribution transformers, and the data locally captured in the data pictures, videos, and all the measurements are locally captured in the drone, and it has a local storage, and these data are then transmitted and stored in the safe storage devices. And as you can see, the drone captures both 4K images, RGB images, and also thermal images. And as you can see, the right hand side is the thermal image of a pole and all the conductors and if there is any hotspot or something abnormality, that can be also be detected using augmented reality. And the 4K cameras, you can see using the 4K cameras, we can actually see the actual physical condition of the poles, the vegetation covers, the sag, etc. The high resolution of the cameras is very useful in these cases, and as we have said, the drones are inbuilt memory cards, so and around one drone can actually fly for one charge can fly around 1 hour. So using 2 to 3 charges, we can actually monitor the whole length of the LT network, and this reduces the time of monitoring, and also we are getting more and more data that we can use in future for detailed analysis. And after all the collection of the data and everything, we are actually we have to now represent and analyze the data for proper for analysis and work on these problems where we have found. The data that we have collected in the drone memory that are represented by a software known as ARU software, and after collection of this data, these are uploaded in the secure cloud platform so that they can be anytime retrieved and analyzed as we require. Moreover, that an exception reports are generated using where are the hotspot points, where are the sags in the conductor, the vegetation covers, all these an exception report is generated automatically and somewhat manually. So and after identification of the problem points in the overhead LT networks, we are actually we are doing preventive maintenance using the using our technicians and others. So that we can avoid the faults and other problems that can be avoided by using preventive maintenance systems. Now, for representation, we are using orthomosaic maps. As you can see in the left hand side picture, the red dots that are given in the pictures are actually the hotspots points that are that we have observed during the measurement using the thermal camera the drone has captured. And moreover that the vector it is actually a vector layer of GIS data superimposed on the map, so that there are many layers. The points where the hotspots, the sags, the actual root line, sag line, all can be implemented layer on layer, and we can select and analyze what problems are there, and then take care of it using preventive maintenance. Now, what are the findings that we have found? The actual case studies. That is the maximum temperature. As you can see, the maximum temperature points are located in this picture. The tree cover, the actual 4K images are helping us to find the tree covers, vegetation cover that can be harmful for the overhead LT network. Other actionable areas, the hotspots can also be identified. The sag lines are identified using and also marked on the system, as you can see here. And also the conductor joints also using the hotspot, and also the physical 4K images, we can see the problem points. And actually, by using all this drone surveillance system, we are actually preventing intelligent preventive maintenance, by virtue of which the exception reports provide an action plan to attend the vulnerable areas. And as you will see, we are working on a priority based on the historical data. It is also a real-time physical monitoring system, because when we are flying the data, there is a technician is always present while the monitoring is going on, and he can see the images, and we can see the images live on the remote controller. There is also a screen attached to it. So while monitoring, if any abnormality is seen by naked eye, then he can recapture the image or get some close-up images on that, so that more problems can be identified. And most of it that we can see that by using this thermal imaging for over 2 years we are implementing this, and we have while by implementation of this, we have found that 30% of reduction in faults have occurred in the overhead LT network by this preventive maintenance. And the key takeaways is that we can actually go forward from this LT overhead network to all 611 kV overhead HT network, and also 33 kV or 132 kV EHT transmission lines that we can also cover using the drone management. Moreover, we can extend this project in the waterlogged areas, because Kolkata has a problem of very waterlogging during the monsoon areas. So the waterlogging areas can be identified using the drone imagery, and same exception reports or problems can be identified on real time, and we can take actions. And in the long term, machine learning algorithms can also be embedded, so that the daily monitoring of vital distribution assets like transformers and others can be obtained, and same preventive maintenance or condition monitoring can be done using this system. Thank you.
Thank you, Mohsen Datta. This is an exemplary, innovative application of drone technology in specifically in distribution sector, where physical security is really concerned. Actually, this reminds us how civilization has moved from Stone Age to Phone Age and to Drone Age. So, thank you for your splendid presentation.
So our next presenter is Mr. S. Majid Razai he's from Brazil, and the paper that he submitted was AI-based predictive maintenance implementation in wind turbine based on SCADA data.
Sorry, this is Manan Pathak?
No, sir, it's S. Majid Razai, and he's from Brazil. So I believe that he is not here yet. We can go ahead and start with our next presentation, which is by Dr. Pratik Bajaria, Customer Success Manager and Product Owner from Oxtra Grid Private Limited. And the paper that he submitted was Power Demand Load Forecasting using Artificial Intelligence and Machine Learning for Power Utilities. So I will now just load his presentation.
Welcome, Dr. Pratik Bajaria.
Pratik, you can come on the dais.
Oxtra Grid Private Limited. He is present there.
Yeah? Yes, sir. He is there.
Welcome, Dr. Pratik Bajaria.
Thank you.
Your very interesting topic, customer success manager and project owner. Your designation is very intriguing designation. You know,
Thank you, ma'am.
yeah. Please.
Okay. So basically, the paper talks about the demand forecasting for power utilities using machine learning. We have been speaking about a lot of ideas in the domain of demand forecasting, right? So the introduction. So like, let's say if I have to speak about when we are looking into the demand supply ratios, that is the place where the entire issue starts, right? Power grid, power systems, they are all looking for maintaining a right demand supply ratio. Now, when I do talk about that, we also want to manage the overall power flow. At the end, you need to make sure that whatever you are generating is being consumed at the end where the loads are being specified, right? Now, having talked about it, what is the overall idea behind generating something called as demand forecasting? We all know, maybe I'll just rehearse it a little bit. We talk about the beforehand power flow management. We talk about accurate demand forecasting and AIML based models. Now, the idea over here is to make sure that the entire solution is giving you an corresponding look forward or an outlook in the future where the overall demand can be looked upon, and you can make predictions so as tomorrow if any of the utilities are making provisions of the generation being supplied to the demand so that the demand supply ratios are maintained, right? Now, there are many algorithms in the literature which apply AIML based solutions, and these are pretty much interesting, pretty much important, because AIML is an algorithm or a model which allows you to incorporate in uncertainties. We all know that demand supply ratios or demand is something which is not certain, right? And that's why many a times past history or the data from the historians allow you to make sure that you can make predictions in the future. Having talked about that, the overall requirements persisting to a smart grid, and we are all talking about buzzwords like the ancillary services or demand response and all those kind of terminologies, right? So when I talk about that, I need to make sure that the ancillary service is being provided on the basis where I know that how tomorrow I am going to generate the power and give it to a particular load or a consumer. And hence, demand forecasting becomes a very relevant topic where any of the utilities would want to know that how the energy is being flown from the generating side to the distribution side, right? Again, having talked about it, optimum demand response is one of the key parameters which makes this particular problem statement relevant. But then again, we are more moving towards net zero, carbon free, and all those kind of terminologies, right? So we are talking about a sustainable solution. And hence, when I do talk about sustainable solution, demand response, demand forecasting, load forecasting, power forecasting, these all terminologies become very much important and significant, right? So what we have done is we tied up hands with a utility, TSN PDCL, where we got an overview and insight into the data. Now again, for any of the AIML models, you know that the most important thing is data, right? And on the basis, we were lucky enough to get some insights into the data. We tried analyzing it, we tried to understand what the data is speaking about. We implemented models, and then on the basis, like as I'm mentioning out here, we got the data for 5 years. And on the basis, we understood that, okay, this particular data can be implemented via an AIML service and can give you a good outlook into the future where the demand can be forecasted. Now, some of the parameters that were given by, TSN PDCL were related to timestamp, maintenance schedules, consumer profiles, consumer counts, holidays, and weather data. Now, if you can see, any of the AIML models requires features, right? So these are the features that we actually took into consideration and that allowed us to model our AIML model. Again, there are a list of AIML models that we have. One of the key and one of the most simplest model is about the gradient boosting, right? So gradient boosting model is the one which we tried implementing, because many a times we actually get fixed into the buzzwords buzzwords that are, like neural nets and SVM and whatnot, right? But then again, many a times, we believe in the fact that, in most of the things can be solved by very simplistic methods. And when I talk about simplistic methods, one of the simplest way of solving a neural net, machine learning problem is using a gradient boosting. So we implemented that. Luckily, I won't call it as lucky because we did a lot of analysis on top of it, and then we understood that XGBoost is something which is giving a good accuracy against neural net models which are computationally cost ineffective. Okay, so this was the architecture that we deployed, wherein we wanted to make sure that we have training and testing sets as normally it goes in a machine learning model, and then at the end when the implementation happens, it can be Dockerized. Okay, when I say Dockerized, it can be packaged into a software where any of the utilities tomorrow, if they want to deploy it, it's not something which is really difficult. Okay, we wanted to make sure it is easily implementable, and hence we made sure that in the entire architecture becomes pretty much easy to use. So these are some of the results. We achieved good amount of accuracy against some of the good papers in the literature. We tried to make sure that all the data, all the solutions that we're giving, they are neck to neck at least. Okay, I mean, it might be that they are poor or it is better or whatever it is, but we try to make sure that at least we are neck to neck, and we found out that our solution is having a good accuracy against all the neural net models, or at least they are peer to peer, making sure that the model that we are claiming that they are cost effective against cost or big O complex neural networks are significantly deployable and accurate. So having talked about it, these are some of the monthly, yearly forecast models. We also tried plotting the scatter plots, which we normally do in order to understand how are the predictions against or the forecast against what is actually happening in the reality, right? And if you can see that the scatter is having some tolerance, but then again, majority of the dot points are actually across the linear point. Okay, so these are the key takeaways, and I'm sorry if I'm closing in really fast or what. Okay, so these are the key takeaways and recommendations. So what I'll do is I'll try to focus on these more because AI/ML are like very specific and straightforward methods, right? At the end, if you have a good feature extraction that you have done, if you have done a cleansing data anomaly which is pretty much in place, then neural net or gradient boosting or decision trees or whatever it is, it becomes like a cakewalk. But then again, make sure that whatever solution that you're giving has a certain problem statement which is being addressed, right? So when I do talk about that, few of the things which are more important when we started looking into and possibly might help, and maybe some of the questions which might help me are related to the topics where we try to understand that what data is actually speaking about. That's what is AI/ML all about it, right? So what we did is that we tried objectifying the problem statement, making some of the key pointers. And when we make key pointers, these are the key takeaway and recommendations which we actually fall into, or which are the points which possibly you guys also might have questions, which probably can be something which can be thought about, like a future aspirational or a future scope of work. So the first key takeaway is related to the accurate demand forecasting tool in modern power grids, where the demand forecasting tool should have the right set of accuracies. I mean, many times it so happens that I provide a prediction, then probably it is not under a particular tolerance level, and then the utility claims for it, and then the money is not given back, right? So similarly, you should make sure that any of the demand forecasting models that you are giving has good accuracy. Okay. Then you have optimum demand response, demand supply, distributed energy sources integration, and overall sustainability. So all in all, the aspect of implementing a demand forecasting is not just about solving a mathematical model. Again, it's not even mathematics, right? You know that you already have tensor flows and scikits and everything with you. All you need to do is you have to just put in the data, make sure that the feature engineering is correct, and boom, everything is correct. Now, we are not solving that problem. We have models. I mean, many of us who might be into IT, we know that everything is like cooked up. The only thing that you need to solve is to make sure that what data actually you're pulling into and what are the objectives. And the key takeaways are exactly those. You want to solve a problem, you want to solve demand response, you want to make sure that any of the utilities are making sure that tomorrow's forecast is being predicted with accuracy, and you want to make sure that everything is sustainable. Again, demand supply ratios is something that needs to be optimized, and that is what we are trying to solve. We are actually coming up with many models. This is one of the key ones that actually we found out and which gave us good accuracy. We are building more on top of it. Probably in the next SIGRE or any of the ISUW meetings, we will provide some more insights into it. Thank you.
Sameer sir, so Dr. Prateek's presentation is done. Do you have any questions?
I have got one query to Dr. Bajaria. Since you have got a predictive model for the ML, and you have, I presume you have taken the test data, training data from the utility. Could you have any chance for validating the accuracy of the prediction from the model you have adapted with the real life result of the customer, your utility data?
Yeah.
Could you,
Yeah, so ma'am, what we have done here is that in all the charts that I am showcasing here, and there are many, actually we have a Power BI tool where we create these charts. And if you can see on the top, I am writing down what is the MAPE against the forecasted and the actual values, right? So wherein you can, we have it for daily, yearly, monthly, 6 monthly, or again, it's just a tool. You can create those MAPs, and the MAPs that we found out is on an annual basis around 11, and these are old models. The newer models are actually having more accuracy compared to what I'm showing out here. So we have created some of the charts and some of the MAPs or metrics that allow you to quantify the differences between actual and the forecasted values.
Okay. Thank you, Dr. Pavaria, for your scintillating presentation, and welcome to the next presenter.
Thank you.
Thank you, Prateek. Now we will be moving ahead with our next presentation, which is going to be on video. Mr. M.L. Sachdeva, sir, and Mr. Narendra Singh Soda. Both sirs have joined us online, and we have a video presentation by them. So, Sameer sir, I will just play the video for you. And
welcome, Mr. Sachdeva, Mother Sachdeva, and Soda Sahab. Please.
They are here, sir. I'll play the video, and in the end, if you have any questions for them, so you can ask them.
Please.
1 minute, sir.
Good morning.
Sameer sir, you are able to hear the video?
Absolutely. Yes,
Okay.
please carry on.
Gentlemen, I am going to discuss on the wearable devices. Wearable devices cover science and sports, and smart devices which contain amalgamated with the sensors and noise sensor, temperature sensor, and other things, and then they do the right thing. Next. Now, in this slide, I am going to discuss what is happening over the world and globe, and how people are facing the calamities and these disasters which are taking place due to climate change. Paris Agreement 2015 has laid down a limit of 1.5 degrees centigrade temperature to and limit the climate changes causing natural disasters, loss of life, infrastructure damage. USA has mentioned 1980 340 days of separate weather and climate disasters since 1980, and also between 80 and 221 and between 17 and 21 has mentioned the difference between the disasters is double. So that shows the things are getting worse day by day. In India, Times of India has mentioned Delhi having temperature of second highest ever, 40 degree 2020, 72 years for record. Pakistan warmest April on record extending back to 1961, above average 4.05 degrees higher by 0.96 than 2 degree highest April temperature in 2010. CA in the conference on 3rd February mentioned 14,000 accidents taking place in average over the 3 years and 5,000 deaths. Lives are lost. Global temperature on rise, so are incidents of disasters, floods, and accidents and damages, and this has to be taken somehow or other control. Wearable and smart devices. Wearable iteration of smart wearable developed in 1985. Smart shirt with a near field communication chip to their with Android Smart phone 2016. Smart shoes include sensors to provide real-time analysis for any metrics 2020. Application of smart cloth in sports, cloth and military industry gain traction 2025. Smart watches like first watch was made in 1972, then wireless smartwatches 1994, PDA smartwatches 2001, and Microsoft Mistake 2004, and so on, since 13. Wearable in power technology adopted early 20th century. In October, in India, heart stick and wear and techniques introduced in 1960 and 1990 respectively. Cover devices to physically borne heart stick method and deploy PPE bare hand technique by workforce and protective jacket against arc flash, safety harness and fall protection. 5G improves data transfer and speed communication, and range of personal electronics are experiencing new personal protective equipment, PPE, possibilities, smartphone and smart watches. World CA in February 23rd, 3rd February 23rd, did mention that all the people working on the line shall wear the PPP and they call it as a wearable clothes, wearable. World Economic Forum, November 2019, survey reports 92% of the corporate leaders believe by 2025, 10% of the people will wear e-clothes connected to internet. Primarily smart clothes monitor heart rate, health-related information, heart rate, respiration rate, temperature, etc. Smart clothes used by wounded incumbents in war due to the impact of bullet sends a radio signal to the control room to convey their fitness status. Digital technology, miniaturization and improved sensors, a few frontier for wearable PPE require make more than simple protective. Modern wearable PPEs are protective and monitor the workplace environments as well as the wearer. The slide shows the protective devices which are C as recommended in the middle. A jacket which shows the various sensors, that is action sensor, external temperature, GPS, monitor, electronic box, communication sensor, and on the right, on the left shows a safety harness and fall protection. These are the devices which are worn to protect the lineman from the electrical discharges and shocks and arc flashover. Now, transmission maintenance is generally done in case of disasters, not by the deadline, but by the live line. And it is not aware whether which line will be live or which line will be. So it has to be done by either the hot stick method or by bare end technique. In hot stick method, we use special type of protective sticks and conforming to IEC 60832, 60895, 61478. And for bare end technique, we use lineman wears fire protective PPE, including static belts and manufacturing from the stainless steel wires and special types of fibers, etc., and conform to IEC mentioned above. Ground operating robots are now the latest one, which are used the arms as a reinforcement of the strength of the workforce, and also drones to perform the inspection and site inspection and distribution, suppression inspection and distribution. Federal Aviation Administration approved Corridor Power and Light to fly drones beyond visual line of sight for surveillance and inspection of west farm in the beach over the on the slide. You can see on the left side is the workman doing the hot stick method of maintenance, and other two right side shows the man touching the bearing technique, and another one is climbing on the light conductor. Now, this slide shows the various tools to be used and also the two-piece conductive suit, which is worn by the when doing the live maintenance. The OSHA standards laid down the minimum distance of the hot stick for various voltage rating. Protective wearables are those wearables which are PPE, but they are to protect individual from harmful AC electric field, electric discharge during live work, current shock from induced voltages, and thermal protection from electric arc. Emission conform exceeds IEC 60895 2020 and less than 3 ohm overall garment resistance, 1 ohm overall garment resistance, 30 ohm glove resistance, and 70 dB shielding factor. Meets and exceed IEC 618482 with 80 dB of 10 calories per centimeter square. The national standards and insurance company, these values are subject to depending upon these requirements. Lineman apparel method. They have to fabric meeting with the APTB and oil resistance isolation of inductive side from human body. It's a highly conductive tape, low level of electric resistance, Nomex reinforcement pads to protect from the abrasion. The whole fabric system is resistant to human sweat and capability to withstand multiple washings. A face shield is also provided to protect from the arc, the head, face, eyes, etc. from and high frequency operation. Arc flash personal protective lesson. This is to protect from the arc which is caused by the flash of the arc, which is temperature is 35 to 20 degrees centigrade at the terminals, and the best cloth for that is monochronic cotton blends are among the best for use for PPE, and the thermal heat, and the heat is 40 centimeter calories per centimeter square. Arc flash personal kit is this. This slide gives the various components like overall, shoes, shield, traction device, and fall protection. The modern wearables are again further defined into augmented reality and virtual reality. Augmented reality, where we classify where augmented reality is non-immersive and virtual reality is immersive. Virtual reality replaces individual viewing, and augmented reality adds to it. New and potentially disruptives. Augmented reality and virtual reality. Augmented reality, virtual reality, non-immersive, immersive, complete with other tasks, talking, listening, taking pictures, messaging, receiving basic nothing. And in case of virtual reality, attention, observing video games, video-based news, and the present day is now the digital twin, which is coming to a highly technical and commercial issue. Voice-driven interference. The communication to recognize the individual voice, the methodology has been developed, and some banking have started this one, and there has been a experience of fake recognition made in client account. Modern wearables, again shown here as augmented reality, watches, smart bands, glasses, smart LVS, and robotic arm. Watches and smart bands, they measure the temperature, pulse, ECG, and barometer and blood pressure, while smart bands protect the individual from falling or losing, or a senior person getting injured, and then the message is sent to the concerned person. Headgears, glasses where in the frame are provided with sensors which measure the messages, which measure the condition, and then send it to the control room. Smart headgear similarly provide this thing. Robotic arm to augment capacity of the this thing by, and this measure at the waist as well as arm. Communication facility. Having said a lot of things on the tools and titles. Now we have to discuss about the communication capability. Communication capability for individual line man is about 30 meters. In case of any accident, any storm, and anything, they will get totally isolated and get cut off from the main source. Communication has to be extended in such a way that it can get extended to the nearest network, so that the message can be given and protection can be done. Similarly, provide broadband speech, narrowband, portable radio apps to fit to tag fencing using rapid indicating polling, etc. Tracking the emergency and rescue team becomes easy, thus making the workplace more efficient and more distant. Apple IP14 and Apple IP14 and Samsung in December 23 launched emergency two-way message via satellite to give messages communication in case of any failure or in case of any power supply. It is also mentioned that the present telephones, present smart sets will be in a position to, sometime will be in a position to communicate through the satellite. Key takeaways. Public utility been employing tools now available for maintenance, including restoration of electrical system damage and increased frequency intensity as they fall out. Amalgamation and augmentation of existing workforce of utility with smart hand-free and hand-free access data trackable, variable to inculcate digital transformation in self and in location and alignment trade, thereby improving efficiency, track and place, health, etc. Wearable PPE, conductive suit, hand gloves, etc. conforming to IC 60985 and flash capability of 40 centimeters are governing the local regulation general insurance. Variable adopted by utility workforce afford protection against flash, electric shock, electrostatic field, radio communication, and improving additional facility by smart wears, e-clothing, GPS, bands, monitor, beam work protection, etc. Workforce better, secured and distinct. Immediate replacement, extension of radio network covering, bringing radio communication affordably and instantly, broadband distinct, and also providing the smartphone through, in case of power shutdown, through the satellite, and that's caused the message sent under the disaster condition. Modern utility workforce with smart wearable drones, powers, and extended time communication, as also smartphone, etc. In task duration can set reduce interruption duration and energy loss, etc. Thank you very much.
Thank you so much, sir, for the video presentation. And may I request Mr. Sameer sir, if they have any questions? Mr. Sachdeva is here with us online. Sameer sir, you're on mute, sir.
Yeah, anybody having any question on Mr. Sasaga's presentation on disruptive innovation for wearables?
I don't know, Chairman, Mr. Sameer Chaudhary, I just want to add a little bit on.
Yes, welcome.
Thank you so much. And thank you for allowing Sachdeva Saab to give presentation through video. In fact, he was indisposed, but in spite of his poor health, he prepared this video and sent it, because I was not very sure of coming and presenting physically, so he made this effort. And thank you, ISGF, for making this presentation in the video format itself.
No, it is our pleasure, sir. Please.
Yeah. My take on the paper is that we were thinking about safety of the personnel who are working in the electrical power utilities earlier, and we were trying to prevent accidents. Now it is going beyond that because of the excellent communication, IoTs, and the digital transformation of the utilities. And in addition to preventing the accidents, and it is also about maintaining the assets in a better manner. At the same time, the physical health condition of the workmen can also be maintained by these wearable devices. And there has been a lot of innovation across in the field, and certainly these are being selectively and progressively used by utilities all over India. as well as abroad, Even in power grid, we have gone for wearable devices and improvements, and the modern, more modern asset management wearable devices are being utilized in the power management and power sector management in India also. Thank you, Mr. Samir Chaudhary, Chairman.
Thank you, sir. Thank you for your valuable observation and your advice also. So, next presentation, welcome speaker, Mr. Parul.
Yes, sir. So next we have Mr. Chintamani Chitnis, Head Power System Control, Tata Power Central Odisha Distribution Limited, and Mr. Rabindranath Tripathi, Team Lead Power System Control, Tata Power Central Odisha Distribution Limited. And the presentation is on centralized and decentralized approach for safe, reliable power supply using IT/OT. So let me just load the presentation, sir.
Mr. Chintamani Chitnis and Mr. Rabindranath Tripathi for your presentation. Please start it.
Network, which actually is a very difficult scenario to manage. So I would just set the context. So Ravi, if you can, yeah. So when we think of what you call automated or centralized control, we normally mean something what is called as automated systems which are there, and that is the OT technology that we have. Now this OT technology, as you see in the what you call map of India, is highly cornered only to the urban part of the country, and that too in cities which are having a large density of load. Now this is actually far from reality when we move down south towards the country, where most of our network is highly spread across a large geography, and that too with a mix of a rural and urban network, with a mix of a automated and a non-automated station. So when we went to Odisha, this was one of the first challenges that we had, to make a kind of a common platform where we would be able to monitor this. And therefore, as you see, Odisha is seen a little different color than the other parts of the country. So this geography is actually somewhere around 1 lakh square kilometers, and of which a part of Odisha is what we are looking at, something around 30,000 square kilometers. So this is what we thought we would start with. So just to give a context in terms of Odisha, this is a place which is abundant in natural resources, large sunshine along the sea coast, and of course various certain other parameters which make it a befitting case to see what we can do in the distribution sector in terms of the number of customers that we would see, the number of, the large land base that we have, some statistics which are a part of a World Bank report which make it more apt in terms of giving away this case. So as we come to Odisha, this is a state which is almost about 30 districts spread across, I told you, about 1 lakh square kilometers. A part of which, as you see, TP Central Odisha is what we are looking after. Now this part of the state has almost about a population of about 1.5 crores with a consumer base of about 28 lakhs. Now this consumer base, if we consider to all the discounts that I had showed earlier, is almost 10 times more than what we see in a normal small kind of a discom. And that is where the challenge lies, with a peak demand ranging somewhere around 1800 megawatt and about approximately 9,500 million units that we serve in the year. Actually, to take you exactly into the topic, if you can go to the next slide. So so this we took over, as I said, on the 1st of June 2020, and then we established, there was actually an existing RAPDRP SCADA system which was installed but not installed. In a way, it was not getting used to the extent that it was to be needed, and we tried to put that in place and brought what is called as a OT system into operations in a span of about 6 months. But this was only a part of the story that we actually kind of activated. What was there would actually come now. So in the next slide, if you see, we have a map of our discom. Now you see various small dots in this map. So these small dots are actually the substations that are spread across the geography. More to the small dots, you would see there are some different colors that are there. One is seen in red, one is seen in green, one is seen in blue. So what you see in the red part of it is actually a local station which is not in automation and it is managed locally, whereas the blue dots are one which are automated and managed centrally. So the central part of Odisha where we come from, that is Bhubaneswar and part of Puri, is actually automated in terms of the same example of an urban area being automated. However, a larger part of geography is actually not looked after, and therefore there is a disparity in the kind of service that we give to our customers, a disparity in the type of reliability levels that we have when we serve these customers. Therefore, we wanted to have a system where we would be able to give a same kind of reliability level, a same kind of operations that we could see. So what you see here is we have a part of Cuttack and Khurda that you see some districts. I mean, don't get on the names part of it. So this is where we operate the OT part of it, and the balance part which is seen in the red is actually the non-SCADA or the non-OT part, which we are trying to operate with an IT system. It will have all the features of a OT system in terms of capturing the relevant parameters in almost real time, but not real time. And then we have both of them speaking to each other in tandem. So this is what we developed in terms of an IT platform. So as we go along, which will tell you exactly what we did. So we developed a tool, what we call as Suraksha Kavach. Now, as you know, Suraksha Kavach is nothing but a safety shield. Now, as the name goes, it of course looks into the operational parameters and also primarily on the earlier topic which was being given in terms of safety, because safety being one of the prime focus in terms of all the DISCOM area that we operate. So this Suraksha Kavach has got inputs coming from various quarters in terms of compliances from the field, in terms of SOPs, in terms of training given to the people, all captured and digitized into it, so that he is able to give me an output where I would be able to serve my customers better. I would be able to give a real-time information to my customer care center. Even the lineman who is operating the field would be able to get on his WhatsApp what is the kind of permit that he is going to work on, which line is isolated and all that. But this is all being done without an OT system. So this is an IT system wherein all these key parameters are getting punched in the field by no less than small operators who have been empowered to give such kind of information, so that this gets assimilated and captured at a central database, and therefore we are able to develop what you see as the reliability dashboards on a very next day. So on a geography of this scale and on a consumer base of this scale, I do not think this has happened anywhere in India. And as we go on, I will try to still decipher as to how and what we did. So we had a conventional approach, which is a centralized power system control center, which is an OT system. And we developed what is called as an area power system control, that is local power system control centers, which are actually stations controlled by a local center without an operational technology, but with an IT system wherein all the parameters get keyed in locally and they are communicated through that blue thing, what you see as a web application that we developed, or a mobile application, or an IT application of Suraksha Kavach that I told. And ultimately, what are we able to get out? We are able to see the compliances in safety. We are able to see that the outage that we give to our consumers is minimal, and this all gets monitored in almost near real time to give you management information, and which can be reviewed by the management to take healthy decisions. So this model actually evolved in a way, and Ravi, I would request you if you can take us through this.
Yeah, so sorry. Moving on, see, this slide speaks of how the gradual evolution process was. So the very first stage was where we took over the system. The system was manually operated primary substations, and as sir rightly pointed out, initially we had some OT integration already there, but it was in non-operational stage. So the first step was to took these into OT integrated, SCADA integrated substation into operation, and we formed a PSCC, and all the balance localized system which were not integrated to the SCADA system, we denoted them as APACC, and we conducted several training sessions. The biggest challenge there was as a change management was the biggest thing that was to be implemented. So SOP training the people there, that was the biggest challenge. And By doing that, what we could do is all the OT based substation as well as the linkage of IT based substation, all these people were now standardized and their standard operating procedures were now established in the platform. So now they were having, we implemented one more layer that is called the IT layer of Suraksha Kavach, where every process was now standardized. Previously, if you see, the processes were localized and everywhere the processes we used were specific to their own location. But with this implementation, we took care of every aspect of the operations that has to be followed diligently and rigidly, and those were established by having a single platform across the DISCOM. By doing this, what we could achieve is, like already pointed out, safety protocol was totally adhered to. That was the biggest achievement there. And now that the whole amount of data was coming to a single place, we integrated our customer call management system into the folio. So the backend data was available to the call center, and anybody giving a call to my call center saying, I am from this area and I am suffering a power outage, what is the reason and about what time it will take to restore my power, they were bang on the information saying that this is the reason that you are out of power and you will get the power supply within this much of time. So these data also helped me to analyze where my gaps were, what I needed to do, where to prioritize, and what outage to prioritize on. So this was the biggest achievement, and the next stage I would say, by this we tried to create a operational model as such, because Odisha typically was a government-owned DISCOM. So across India we find this mix of rural and urban pockets across India. So this model that we have prepared is a very unique model, where rural, urban kind of mix and match were there, IT, OT mix and match were there, and it is extremely cost effective. Whatever was available, that was taken up, and whatever wasn't available, that was integrated into the system from the back end. This model is extremely scalable. It doesn't have any size limitation. Any number of substations can be added, can be detached from it, and this expansion can be rapid. We have done this over the period of 1.5 years, but we see that now that we have a process in place, this can be rapidly deployed in a time frame of say 4 to 5 months in any DISCOM that you take. So coming to the last point, it is extremely deployable. Now I have just broken it into 8 simple steps, where we can which can act as a magic band, and we can tell that yes, we have got one DISCOM, follow this step 1, 2, 3, 4, 5, and whoosh, the entire DISCOM operations has now been centralized. It is monitored from 1.8. You have a central data availability, and you have everything that you need to go on and call yourself and par excellence DISCOM. Thank you. We would be happy to take.
Just to close, just one last slide will be there. To close what we are telling in terms of what are the key takeaways that we would like to bring forth, is that this is a unique model which can be taken up and deployed in any of the DISCOMs across India, and which have got a very large potential in terms of improving the operational excellence. And also, not only that OT is going to help us, it is the IT platform and the various other facets of the model that we talked upon can actually make this replicable across India. And that is the secret of what we see in Odisha today, being deployed across all the 4 DISCOMs, and as we move on to other DISCOMs as we take. That is what we had to give. Thank you.
Thank you all.
Oh, thank you, Mr. Tamani Chitnesh and Mr. Abhinanath Tripathi, for your fantastic presentation and example of convergence of IT and OT, which actually invigorates me more about your Suraksha Kavach model, which is really unique model and can be replicated by all DISCOMs. I was just wondering, as you have done for this Suraksha Kavach, what are the cyber security factors you have taken care or implemented, if you can highlight?
Sir, as already said by my 2 of my previous colleagues in Tadapa, we have a standard cyber security protocol that we follow. We have a 2 level of firewalls that were built. A local firewall is there, central firewall is there, and here we have also taken it a step further. We have restricted the users' access to it by means of variable VPN networks, and there is a day on day basis the password changes automatically. We will have to reset the password
to log into this. So all these aspects are taken care of as per the standard process that has been laid for by the parent company, sir.
Thank you, Mr. Tripathi and Mr. Chitne.
Thank you, sir.
I hope all the participants and even the speakers have enjoyed and appreciated your move. Next presentation, Parul.
Yes, sir. Thank you so much for the presentation, Mr. Chitnis and Mr. Tripathi. We'll be now moving forward with our next presenter, Mr. Manan Pathak. He is Assistant Professor, Department of Electrical Engineering, Silver Oak University. And the presentation is on feasibility study for implementing smart interactive street lighting and the smart city concept. I'll just quickly load the presentation.
Mr. Manan Pathak. We are very fortunate to have purely academic persons over here in the panel. So I invite you to present your paper in this forum.
Thank you, sir.
Please, thank you. Welcome, Mr.
Yes.
Pathak.
Yes.
Professor, sir, you can start.
Yes, sir. Thank you very much. First of all, I would like to thank ISGF and ISUW for providing me the platform for representing my research paper. As I'm from academic background and there are very few authors I have seen the list were from academics, only 3 I guess. So really thankful to all the organizers and especially to the coordinators who are continuously working on this domain. So yes, I'm basically from Silver Oak University and my proposed title is on feasibility study for implementing smart street lighting concept under the smart city. So it would be an interactive street lighting. So whatever data we would like to add, we will be getting some sort of output. So everyone is talking about AI, machine learning and all, kind of digitalization of all so-called grid. So this is one of the concepts that we would like to add. As it is a feasibility study, we have yet not been implemented, but yes, it is a proposed model and yet submitted a design patterns and for funding opportunities also we are looking for some grants from Government of India. So as a brief, as I'm an academician, so basically just would like to share some of the numbers here. The world's cities are growing and in general 23% of people are living in the cities, and if there will be more populations, then there will be a chaos that we all know. So this increases the urbanization pose problem for the futures, and local resources such as waters and electricity's supply are the kind of increase in terms of amount of strain. In general, as per the standard definition of smart street lighting or smart lighting is a term used by lighting and networking companies to describe LEDs lighting which has an ability to control by a central management system CMS in order to provide a functional and flexible lighting system. What are the main context of this presentation is the investigation for implementing smart street lights with the following objectives. So let's just begin with the basic boundary conditions that we would like to identify. So as per the data, the hardware solution must fit within the confines of the smart street light housing roughly by the cross-section area of 200 cross 100 cross 60 millimeters, and the weight should not more than 500 grams. That was the basic constraint. In terms of traffic detection, had to be a reliable from the overhead configuration. So at least 5.5 meter height would be the preferred where we can put our sensors, which might be identified traffic types in case of vehicles, cyclists and pedestrian. The combined hardware cost, yes, again cost would be the biggest issue. Everyone would like to implement a smart city, smart concept, but where are the fundings where we are getting some sort of money? So kind of as an optimal solution, what we are proposing, the cost should be less than 10,000 rupees, as we can find multiple smart street lights across the globe, and the overall costing might varies from maybe 15,000 to 90,000, maybe more than 1 lakh rupees, depending on which type of sensors and which type of applications we would like to deal with. The detection system had to be made already existing and a commercially available component as a sensor technologies to determine if the current state-of-art system would function in a given circumstances or not. So again, we need to verify whether the system is visible enough or not. Now, what are the relevance in that in general? So, would like to address certain questions as per the presentation. So, how can smart street lighting be leveraged or delivered to the smart cities? How it connects with the two? As Regi sir had already mentioned in his opening ceremony of this conference that Gift City in Gujarat is a kind of new smart cities concept has been implemented, and there are many new concepts has been added in that. So one of the concept can be added in that as a smart city concept, smart street lighting. So what are the technological options to enable the smart lighting? What are some of the considerations that could be impactful for the smart lighting system? What are the potential pathways for implementing this? And what other options are available for delivering to smart cities? So it's totally up to us what we want to be done under this smart city concept with the help of smart street lighting concept. So these are some sort of sensor technologies that can be implemented, like smart cities in terms of sensors and hardwares, then smart illuminations, connectivity in terms of RFID, maybe with the help of Bluetooth, Wi-Fi connectivity, even with the help of ZigBee as a new communication technologies for smart grid can also be implemented with the same. Then we'll try to provide all the data to the cloud, and with the help of control management system, we can have a desired solution as an event required. These are the proposed design that we wish to implement as a concept of a smart interactive street lighting system. These are the main component through which we can enable the overall problem that needs to be solved with the help of certain domains. So initially on the top of solar, like street light, we do have solar panel with a different capacity depending on which type of concepts we are implementing. We are implementing the LED lamps, then sensors and actuators will be there. As mentioned, that the height of that sensors and actuators should be above 5.5 meters, so that it can easily able to detect and it can easily able to identify which kind of applications we are dealing with. Then yes, of course, as an electric mobility, we might have an option to have a charging infrastructure inbuilt in that smart street light concept. So we do have a battery bank, and yes, if visible, depending on yes which area we are implementing smart cities, we can have a charging store. So at least we can charge a two-wheeler vehicles nearby that vicinity of that smart street light. And yes, of course, it can identify it with on-off control, dimming mechanism would be there, scheduling of that can be implemented, monitoring, alertness and analytics can also be implemented. So yes, somehow we can connect the overall data to the cloud, and yes, maybe traffic control can also be accessed the data, and maybe with the help of CCTV cameras and all other kind of considerations can be done effectively. So yes, a brief about which kind of components that we are using it, like solar panel, depending on the feasibility, which kind of material we are using. Sensors and actuators, it might include the light sources, lamp sockets, ballast drivers, smart street lighting controllers in terms of illumination level. Fast charging slots can also be implemented. Again, that depends on which battery bank we are using and how much capacity we do have as per the availability of raw materials and all. Energy efficient LED lamps can also be implemented as per the NEMA standards, and Zaga controllers we can easily able to implement the same. Yes, so just by implementing certain concept of smart cities, what we propose that by having this as a smart interactive street light, we can fulfill basic applications to the proposed model. The first and foremost application is a vehicle movement based innovation smart highway lighting system. So of course, depending on the predicted data as per 2050, there will be extra highways available with an adjacent of R2 of 0.90. An extra of 3 to 4.7 million kilometers of road will be paved, and depending on that, again, if we can have certain feasibility of implementing smart street light with a cost-effective analysis can help us to deal with the certain applications. Second application that we proposed is like auto intensity regulations of smart lighting using the Arduino programming. So yes, again, with the help of smart communication mechanisms, we have multiple options to select the required applications like ZigBee, Bluetooth, Wi-Fi and all. So depending on that, again, we can connect to the central monitoring systems and we can provide a real-time data. That's what we need as an engineer, as an analyst. We need to verify all the data, and yes, we can fulfill the basic need of it. Third application that we wish can be proposed with the help of smart street light concept is smart LED street lighting system with a web-based management system. So yes, overall data can be fetched to the web, and the overall considerations can be implemented, and will have a real-time visibility. And definitely with the help of that, we can have a feasibility check analysis, and we can have some sort of solutions as per the contingency analysis can be implemented. Fourth, that is energy efficient smart street lighting mechanisms, and last would be the smart street lighting for energy saving based on vehicular traffic volume. So again, as a traffic control, the biggest issue nowadays in India is traffic management, right? So that can also be implemented again depending on which type of considerations we are dealing with, in which area we wish to implement certain smart grid concept under smart city domain. So maybe a general takeaway from this presentation that this finding indicates that rural area, a kind of developing area that we need to link up with the cities, so-called metro cities, which tends to have fewer public transport options, are less likely to have an implemented of transmission optimization solutions. The literature as per the basic data has suggested that it is possible to link between support and findings of the vulnerability within the home and the level of physical activities with both warrant future investigation in the future studies. The proposed model of smart street lighting represents that the feasibility to implement cost-effective smart electric street lighting, that is the future of the developing countries like India, as we all are running across smart grid, smart city concepts and all. So cost-effective analysis must be there. So maybe if we can think as per the thumb rule, if we can identify the smart interactive street lighting of the cost less than 25,000, then it would be more feasible, which can fulfill all the basic applications. By adopting such concepts, all the proposed applications, including development of smart, small capacity electric vehicle charging infrastructure, traffic management, dimming project, the uses of renewable energy sources, etc., can be fulfilled and manage the effective representation of the smart city concept. So that's what the basic presentation that we had made. Thank you very much, and need your suggestions for the upgradation of this project. Thank you very much, sir.
Thank you, thank you, thank you, Patak Saab, Professor Saab.
Thank you.
Your this thing is very scintillating as far as street lighting the subject is concerned. You have made it so interesting and intriguing. The special point which I note is that web-based management system for the street lighting.
Yes, sir.
That's a very unique proposition.
Yes,
so I would like to know if any cyber security considerations have been taken by you in this proposal for the web-based management system for the street light.
Yes, sir. Sir, as such, we have not like implemented or considered this cyber security based concept, but yes, definitely, as per your suggestion, we'll try to look forward it and we'll try to verify as we are dealing with this web-based mechanism. So definitely there is a need of cyber security concept. So surely, sir, we'll try to implement it.
Thank you, Professor Sir.
Thank you.
For your scintillating presentation. I hope all the
Thank you very much, sir.
Speakers and the audience have enjoyed your and appreciated your subject. Next presentation, Parul.
Yes, sir. Thank you, Manan, for the presentation. Sir, I would like to inform that Miss Devika, she was number one. She had a number one slot earlier, but since she couldn't make it at that time, we have her now, and we will have her presentation now. So
good, very good. Welcome, Devika Jay.
So Miss Devika
CEO,
yes, yes,
yeah,
sir.
welcome.
And the paper that she presented was a framework for VAPT services in digital substation.
Hello everyone, I'm Devika and I'm from Grid Sentry. Grid Sentry is basically a startup and we are working towards securing power grid against cyber attacks. So as a first step that we are here is to provide a framework for VAPT services in digital substations, and that is why we have a paper here today.
Share again.
Yeah, to this audience, I don't have to introduce what a digital substation is, but for introduction purpose, I've kept a slide what a digital substation would look like with the process level, the station bus level, and the reporting to the control center. Why this is relevant here is because unlike any other system that we have here, substation, especially when it comes to digital substation, at the level of goose packets and sample values, you have something like an unencrypted message flowing in the network, and also because of its multicast prototype or the level protocol that we have there, you have an unacknowledged message. So which means that if there is any attack by any chance, like if a maintenance engineer connects a laptop to a relay or something, by that case, you have an attack that might be possible, and hence the first thing that we can have over there is to follow the cybersecurity best practices and hygiene. And over there, the first key practice that we have to have regularly as per the government guidelines also is to have a VAPT service. So the key concept over there in any vulnerability assessment and penetration testing in digital substation is to have a defense in depth, because that is how a digital substation is. It's quite complicated in the sense of its network topology, the unique network protocols that are flowing there in the network, and at the same time, as I was saying, you have an unencrypted network. Encryption is not allowed in such a situation because goose packets, the response and transmission time should be less than 3 milliseconds, which makes it quite difficult to protect, and thus a defense in depth mechanism is what to be practiced in any digital substation. So the first key that we have over here is vulnerability assessment. I don't combine both together. Vulnerability assessment is to be taken separate, penetration testing is to be taken as a separate entity altogether. When it comes to vulnerability assessment, it is much more like an audit mechanism, whereas when it comes to penetration testing, you are taking the shoes of the attacker and trying to attack your network and finding out how vulnerable is your system in any case. Why this is a challenge as such in substations? Because you don't have a standardized procedure. You have a supermarket of standards there, IEC 62443, NERC-CIP. For IEDs, you have IEEE 1686. You have separate standards for network switches. You have a whole standard that says what are the standards to be referred to, which is IEEE C 37240. So you have a set of standards, and for any site engineer, it will be very difficult to get it very comprehensive enough. So that is one of the key challenges that we have. When it comes to penetration testing, you can't do it on any live system at all, because you know how critical the system is. You can't just mess up with it. So these are the key challenges that are there when it comes to doing a VAPT in any substation. So the approach that we have over here is to have a tool which would help any site engineer to do the vulnerability assessment based upon the standards that are available in the IEEE or the IEC, etc. And then have a penetration testing which is based on the MITRE ATT&CK framework. I think MITRE ATT&CK framework must be familiar with people. It is mostly used in the IT, and it has now developed into the ICS network also. So what we do is we have a VA tool which is based on standards and a penetration testing tool which is mapped to the MITRE ATT&CK framework. The VAPT framework that we propose here has three keywords. First is to create, map, and then to analyze. So when it comes to vulnerability assessment, the first step is to have the asset creation done. You need to identify all your assets, the make, model, firmware, etc. Create a database for it, and according to that, you map it to the standards. Like if you have a set of IEDs, then you map it to IEEE 1686 and find out whether the checklist provided by IEEE 1686 is satisfied. So this is just a general, a higher level version, because if it's an IED, then it gets mapped to a particular standard. Now the next step over here is to identify the vulnerabilities that are already identified by the OEMs. Given a make, model, firmware, you will have to identify whether there are vulnerabilities associated with it identified by the OEMs, and accordingly the patch management has to be done. Recently from NTPC, I came to know that 85 GB around patch management is done 6 monthly. So which is a quite huge quite huge effort from a human perspective. So a tool would be much more effective in that case. So that is what a map would do. From the IED perspective, it maps to the standards. From the make model perspective, it will map to the required vulnerability database that are already there. There are many databases, open source databases like National Vulnerability Database. Even for each OEMs, there are their own threat intelligence team who is identifying these vulnerabilities and providing patch management. Accordingly, based on what we have, we provide a tool which will analyze the risk that is associated with any substation just with the asset and the management related activities. So this part alone would be the vulnerability assessment in any digital substation. The same flow will happen to the penetration testing also, but it's slightly different. You are now the attacker. So the attacker now will have to create exploits on the messages of the network and then accordingly map this to the MITRE attack framework. So MITRE attack framework is basically how you attack. It's like an attack tree. You have a target, you have a starting point. Then you find out the ways that you can reach out to that particular objective. I'll get to that in the detail. It will be quite more representative here, but just to explain what the flow over here is. So once you create an exploit, you map it. Based on the map, then you analyze how risky is your network. So that is the penetration testing part of it. So the keywords in any framework over here that we have, be it vulnerability assessment or penetration testing, is to create, then map it to the standards or the framework for the attack, and then analyze how risky is your system. So the first things that we have to identify is, like I've been saying, the assets, like you have host devices, software applications which belong to the EMS and SCADA system, and then you have embedded devices and network devices which form the protection and control network. So these will form the assets required for doing the vulnerability assessment. Now coming to the penetration testing part. So what you see on the left side of this slide is that the first objective of any attacker would be to disrupt the substation operation. So for that, he has to gain access to the LAN or the station bus. From there are multiple paths by which he can achieve this. So this is basically the attack tree which can be identified using the MITRE attack framework that we have in any IECS framework. From this, then there is EPRI NESCOR framework that will help us to identify what are the likelihood scores of such an attack. So the classification that happens there is how much skill should the attacker have. If it is a high skilled requirement, the likelihood score is very low, because that is quite an assumption that is being made now, but I don't think that would be valid, because with ChatGPT and things like that, even attackers are now getting very smart enough. So the skill required and a high skill requirement with a likelihood score with very few, like 0.3, is not quite very likely in the coming future. Then how accessible is that attack? What is the attack vector, and what is the common vulnerability? Based on this, the likelihood scores of any attack is identified, and accordingly you have a risk assessment done for your substation. So what we have done right now is, we are incubated at IISc Bangalore and we have a test bed there. Based on that, we have created exploits on the substation network, which is like to first gain access to the LAN or the station bus, capture the circuit breaker control packets, modify the circuit breaker control packets, and accordingly open or close the circuit breaker. So this is like an automated system. Why an automation system is required? Because if you have to do a penetration testing, this is basically penetration test that is happening. So penetration test can't be done on a live system. You need to take a shutdown. You just can't be experimenting things, because you know how critical a substation outage is. You just have a few hours for maintenance. So within that hours, you will have to create your exploit, see how risky is your system. So these things should be automated, and that is why a tool and a corresponding framework is required. So gaining access to LAN substations, so this is what the exploit that is being created here. To create this gain to access, there are many ways. You can exploit the remote services, you can have internet accessible devices, you can use your pen drives, etc. And these things are identified by your MITRE attack framework. That is why you are mapping it to a MITRE attack framework. Accordingly, you can capture the circuit breaker control packets using network sniffing, which can be done using command line interface, scripting, etc. You modify the circuit breaker control packets by spoofing it, you can manipulate it, etc. So as the level increases right now, you can see that to gain access, you don't need much of a skill. But when you have to capture, you have a slightly lesser likelihood there. Further lesser likelihood when you have to modify the circuit breaker. And this likelihood is totally based upon the skill of the attacker. So if you have a highly skilled attacker, these probabilities would naturally be high. And you can open and close the circuit breaker. So right now, these are the guidelines that are there based upon the skill required. And accordingly, the risk assessment of the substation is done. So the key takeaway is, for any substation, VAPT is not together a coined word. Vulnerability assessment should be taken as separate and penetration testing is separate, mainly because VA is much more like an offline activity. Penetration testing is to be done on the live on the system as such during shutdown practices. And vulnerability assessment, you have list of standards there to be followed, and each standard has its own importance, and thus a tool is required to make things easier for any substation engineer. Penetration testing is basically the attack tree that is getting developed through MITRE ATT&CK framework, and see how likely is your system to be attacked. And thus the likelihood and impact scores can be given, and you can see how mature is your system with respect to cyber security. So that's all. Thank you.
Yes, sir. So, sir, with this we have ended our group 1 for technical paper presentations, and so we covered the themes cybersecurity for the digitalized grids, disruptive innovations for utilities, and smart grids for smart cities. Sami sir, I would like to thank you very much for taking the time out from your schedule and chairing this session today. The next session we will be covering the themes electric mobility, foundational blocks for smart grids, and India at 100 in 2047, vision for the Indian power system. And the chair for this session is Mr. N. Murugesan, former Director General, CPRI and advisor ISGF. Before starting the session, I would request Murugesan sir to kindly come in front and present the memento of thanks to our authors who have presented in the first session. So starting with Ms. Devika. Ma'am, can you please come in front? For Mr. Gadvi, Mr. Mukesh Gadvi, please come in front, sir. Mr. Ravi Sahu and Mr. Ashish Mahatre, sir. Thank you so much, sir. Mr. Ganesh Mane, sir. I would like to invite Mr. Ravi Sahu again for a picture and memento of thanks. Thank you so much, sir, for the presentation. Mr. Prateek, thank you so much, Prateek, for the presentation. So, Mr. Chintamani Chitnis and Mr. Rabindranath Tripathi, please come in front, sir. In the end, we'll have a group picture. I request you not to leave right now. Thank you, sir. Mr. Manan Pathak, please come in front. Now I request all our authors who have presented in session 1 for a group picture. Please come in front, everyone.